first off, water displacement just means that we collected this by reacting it and then bubbling it through water. And that means that there is water that's evaporated that's getting in the way of our measurements. And we need to get rid of that water. So what we do is we figure out the pressure of oxygen alone so we can determine the moles of oxygen. So to do that, we do our Daltons. I change my pressure to ATMs because ATMs is the best unit you should use for pressure. And then I just take this, okay, my pressure total equals pressure oxygen plus pressure water. Well, I subtract pressure water to both sides. So my pressure oxygen is equal to my total pressure minus the water, as you can see here. I do that and I find the pressure of just the oxygen. So you'll see that 0.04 atmospheres of the water, that gets taken out. Now that I have pressure of my oxygen alone, I can then do Pivnert. I got to get rid of the grade killer, and I got to make sure that everything is in liters. Oh, you can't see my laser pointer, I'm sorry. You need to make sure it is in liters, and you need to make sure it is in Kelvin. But then you've got atmosphere, liter, and Kelvin, which means you're going to wind up with moles when you're done. Because remember, you always want liters, Kelvin, and atmospheres, and moles. As long as you stick to those 4 units, you'll be fine. Sometimes, though, we can add another question to this. In this case, what we want is how many milliliters of hydrogen peroxide was there at the beginning. This basically just turns it into a stoic question, so it's really not that big of a deal. You make the equation, you then sit there and you go, okay, here's my moles of oxygen from earlier. I do my stoic step, taking moles of oxygen to moles of peroxide, and then you're dealing with grams and you're dealing with milliliters. This is all stuff we've done before, but I need to remind you that it still exists, and you can't think that you should forget it, because you should not forget it.